Oh, okay, let's look at the frequency response a bit more, continuing our discussion from last time. And of course, we're talking about the frequency response of discrete time systems, and want to look at the periodicity actually of the frequency response. So again, given system transfer function, if we evaluate that at e to the j omega, this is on the unit circle, and we get h e to the j omega, which is our frequency response for a periodic input, sinusoidal input in this case, cosine of omega 0 n plus theta, then the corresponding output, y of n, is equal to the amplitude of the input times the magnitude response evaluated at the frequency of the input, and then the output will also be a sinusoid at the same frequency, and then with an additional phase shift equal to the phase response of our system, and evaluated at the frequency of the input. Okay. Can e to the j omega is a point on the unit circle. So this is the circle in the complex z plane with radius 1. So the 4 points on the axis, on the real axis, we'd have 1 and minus 1, and then the points on the imaginary axis would be j and minus j would be those 4 points on the unit circle. E to the j omega is this point that makes angle omega with the real axis here. So as for omega equal to 0, e to the j 0 is 1. For omega equal to pi over 2, e to the j pi over 2 is j. For omega equal to 180 degrees, or pi rather in radians, e to the j pi is minus 1. And for e to the j 3 pi over 2, or e to the j minus pi over 2, that's equal to minus j. Again, from Euler's formula, we have this is equal to cosine plus j sine omega. Of course, it is an exponential form already with an implicit radius here of 1. But you can see from either geometrically from e to the j omega being a point on the unit circle, or equivalently just by evaluating if omega increases by an integer multiple of 2 pi. Again, that would just wrap us, if k is equal to 1, 2 pi radian advance would bring us back to the same point on the unit circle. K equal to 2, that would be 2 revolutions, but again we're back to the same point. And so this is equal to the e to the j omega. Again, you can prove that from Euler's formula pretty easily. Cosine omega plus k 2 pi is cosine omega, and similarly for sine omega. So this is true for integer k. So since e to the j omega is periodic with a period of 2 pi, h e to the j omega is periodic in omega. So The magnitude and phase are usually plotted, magnitude and phase response are usually plotted over magnitude of h and angle of h are usually graphed or plotted over the range minus pi center equal to omega less than pi. Sometimes you may also see the plots done from 0 to 2 pi as well. So we'll talk a little bit more about this periodicity of the frequency response and periodicity of sinusoids in general in the next video.